Welcome to the first lecture on the course on programming data structures and algorithms in Python. Let's start with the basic definition of what we mean by an algorithm and what programming is. As most of you probably know, an algorithm is a description of how to systematically perform some task. So an algorithm consists of a sequence of steps which we can think of as a recipe in order to achieve something. So the word recipe, of course, comes from cooking, where we have a list of ingredients and then a sequence of steps to prepare a dish. So in the same way, an algorithm is a way to prepare something or to achieve a given task. So in the context of our thing, a recipe is what we call a program. And we write down a program using a programming language. So the goal of a programming language is to be able to describe the sequence of steps that are required and to also describe how we might pursue different sequences of steps if different things happen in between. So the notion of a step is something that can be performed by whatever is executing the algorithm. Now a program need not be executed by a machine, although that will be the typical context of computer programming, where we expect a computer to execute our steps. A program could also be executed by a person. For instance, supposing the task at hand is to prepare a hall for a function. So this will consist of different steps, such as cleaning the room, preparing the stage, making sure the decorations are up, arranging the chairs, and so on. This will be executed by a team of people. Now, depending on the expertise and the experience of this group of people, you can describe this algorithm at different levels of detail. For instance, an instruction such as arrange the chairs would make sense if the people involved know exactly what is expected. On the other hand, if this is a new group of people who have never done this before, you might need to describe the step in more detail. For instance, you might want to say that arrange the chairs in 8 rows and put 10 chairs in each row. So the notion of a step is subjective. It depends on what we expect of the person or the machine which is executing the algorithm. And in terms of that capability, we describe the algorithm itself. Our focus in this course is going to be on computer algorithms. And typically these algorithms manipulate information. The most basic kind of algorithm that all of us are familiar with from high school is an algorithm that computes numerical functions. For instance, we could have an algorithm which takes two numbers x and y and computes x to the power y. So we have seen any number of such functions in school, for example, to compute square root of x. So what we do in school is we have a complicated way to compute square root of x, or we might have x divided by y where we do this long division and so on. Right? So these are all algorithms which compute values given one or more numbers. They compute the output of this function. But all of us who have used computers know that many other things also fall within the realm of computation. For instance, if we use a spreadsheet to arrange information and then we want to sort a column. So this involves rearranging the items in the column in some order, either an ascending order or a descending order. So reorganizing information is also a computational task, and we need to know how to do this algorithmically. We also see computations around us in our day-to-day lives. For instance, when we go to a travel booking site and we try to book a flight from one city to another city, it will offer to arrange the flights in terms of the minimum time or the minimum cost. So these are optimization problems. This involves also arranging information in a particular way and then computing some quantity that we desire. In this case, we want to know A, that we can get from A to B, and B, among all the different ways we can get from A to B, we want the optimum one. And of course, there are very, very many more things that we see day to day which are executed by computer programs. We can play games. For instance, we can solve Sudoku, or we can play chess against a program. When we use a word processor to type a document, or even when we use our cell phones to type SMS messages, the computer suggests corrections in our spelling. Okay? So we will look at some of these things in this course, but the point is to note that a program in our context is anything that looks at information and manipulates it to a given requirement. So it's not only a question of taking a number in and putting a number out. It could involve rearranging things. It could involve computing more complicated things. It could involve organizing the information in a particular way so these computations become more tractable, and that is what we call a data structure.